All right, I've officially finished the Fire Weather Principles chapter in Fire in California's Ecosystems, and it was actually perfect timing for what happened today on the Central Coast. We've had a heat wave this entire week, and then today was the peak of that heat wave. We had triple digit temperatures for some of our mountains and valleys. Along the coast, we are even seeing some mid 90s. Santa Cruz is 90, I think, 7 degrees today. And then, not a big surprise, but since we've had a period of heat over the last few days, could call it a heat wave. We've also had some very dry air, and then I was just waiting for some fires to start popping up. And what do you know, peak of the heat wave today, we start to see some fires. I have watch duty on my phone that alerts me when there's fires in the counties that I follow, and it started pinging off this afternoon at the hottest, driest part of the day. So that wasn't exactly a big surprise, and it also wasn't a big surprise that these fires didn't really go out of control. Now, that might not make sense when I just said we had temperatures in the mid to high 90s, even some triple digits. There was a period of heat, so we had a lot of drying of our fuels over this last week. But the reason that when I saw the alerts on my phone, I wasn't all that worried about them was because the winds are extremely calm. So that's where fire weather principles is something that's very important to know, because you need to recognize that there's lots of different factors when it comes to wildfire in California and forecasting wildfire. And it's no single factor that is the most important. Like if it's really hot out, wildfire is going to be terrible. Or if you have a ton of wind, wildfire is going to be terrible. But it's usually the interplay between all of those factors. So it's a bit more difficult than just some singular linear analysis, but that's all part of forecasting right there. So today it was hot and dry, but it was not windy at all, and it hasn't been windy this entire week. I tried to look at a sounding, and it didn't look like there was an inversion or anything in the atmosphere where the atmosphere is very stable, but there's just a big high pressure system overhead, and there's just very weak winds across the Central Coast. So again, this is the key parts of fire weather principles. It's the interplay of all of these different variables. So where you're going to have the most extreme fire behavior, and maybe when you look at your phone and you see a fire popped up and then the alarm bell should really start ringing, is if you have the combination of a large number of those variables. It's hot, dry, and windy. That's actually one of the wildfire indices. It's called, indice means basically just a equation for fire danger, and one of them is actually called hot, dry, windy. Very well named. You could maybe add in stability there as well. The more unstable the atmosphere is, usually the more wind you're going to have at the surface. So maybe that's kind of factored into your wind equation. But the great analogy that was used in Fire in California's Ecosystems when I was reading that this week to explain stability, because honestly that's always been a bit of the weak point in my forecasting, is they said just imagine a wood stove, and imagine you have a damper closed on it. Your fire in there is not going to be very intense. And then if you open that damper, all of a sudden you have a lot of airflow through there, more oxygen's getting to the fire, and then that fire is going to become a lot more intense. And the same thing with the atmosphere. If you have cold air below warm air, that means you have more dense air underneath less dense air. So the atmosphere is kind of how it wants to be. It's very stable. But it's also inverted, because usually the air gets cooler as you go up with height. That makes sense. If you imagine you were to open the window on an airplane, not a good idea, I wouldn't suggest it, but the air out there would be very cold, because air gets colder as you get farther away from the surface in the troposphere. But when that's flipped, or it's inverted, and it actually gets warmer as you go up, that's what you call an inversion. That's very stable atmosphere. The density is more dense, below, less dense. Now, in an atmosphere that's unstable, like when that damper is opened up, that's going to promote a lot of rising motion. That means if you just assume that a rising air parcel is going, an unsaturated one, is going to cool at 9.8 centimeters per kilometer, if the atmosphere is cooling more slowly than that, so your atmosphere is cooling more slowly, which means your atmosphere is going to be warmer than that air parcel rising up, that means the air parcel is not going to want to rise up. So then it's going to stay down. But let's say that your environment is actually cooling faster than the air parcel. So let's say your environment is cooling at 11 degrees Celsius per kilometer, and your air parcel is cooling at that 9.8. That means your environment is going to be colder, your air parcel is going to be warmer, less dense, and that's going to rise up. That's just kind of the science behind stability. I wanted to prove to myself that I could explain it again, because when I started this week, that was my weak point in fire weather forecasting, and I even just confused myself a little bit more looking at a skew-T diagram. Forgot how difficult those were to read. Watched a good video by my advisor, Dr. Patrick Brown. He has a good breakdown of how to read a skew-T on YouTube, and I think it started to come back to me a little bit, but I was trying to figure out if there was an inversion out there today, and turns out all you need to look at on the skew-T is your temperature getting warmer as you actually go up in altitude. I didn't see that today, so we can say that there wasn't an inversion today, so it wasn't very stable out there. But the key reason that I personally wasn't worried about the wildfires taking off today was because it wasn't all that windy. So with all that being said, maybe I should just break down what are the key fire weather factors, now that I've sort of rambled for probably, 7 or 8 minutes. Why is each of those important, and how does that change throughout the year? So the first one is temperature. So we have, I'll just name them all first. Temperature, wind, humidity. Then you could say stability, also throw precipitation in there. But the main ones I usually look at are temperature, wind, and humidity when I'm doing my wildfire forecasting. Temperature, that one's easy. The warmer it gets, typically the worse your fire danger is going to be. And the reason for that is, you could say partially because maybe it gets your fuels a bit closer to that combustion temperature, but much more so it has to do with the fact that as your atmosphere becomes warmer, it can hold more moisture or hold more water vapor. So then your relative humidity is going to go down. Interestingly, relative humidity isn't a measure of how much moisture is in the atmosphere. Relative humidity is how much moisture is in the atmosphere divided by how much moisture the atmosphere could hold. So it's going to be a factor of temperature. As the atmosphere gets warmer, it can hold more moisture, so your relative humidity is going to go down. And then the reason that's important, so now going from temperature to relative humidity, if your relative humidity is low, it is going to dry out your fuels. If your relative humidity is high, it's going to bring some moisture back into your fuels. And you can kind of think of the boundary between the two. You have your plant and you have the air. And if there's more moisture in your plant than is in the air, then the air is going to almost try to suck out some of the moisture from that plant to try to balance things out. And luckily that doesn't happen too quickly. It happens faster in very fine fuels like grasses because there's a much higher surface area to volume ratio. It happens much slower in trees. It's a good thing because otherwise trees would be able to just dry out very quickly throughout the summer, and they're able to hold on to a bit more moisture, which is a good thing. But let's say your atmosphere has more moisture than your plant. Then your plant is actually going to be pulling some of that moisture out of the atmosphere and increasing its moisture. So the atmosphere-plant interactions are trying to balance each other out, and they do it more slowly as your plants get larger, typically. So grasses, that might respond to the environment in about an hour. You have, 1 hour fuels, you have 10-hour fuels, 100-hour fuels would be something about the size of your wrist, and then that's going to, you guessed it, respond to the atmosphere in about 100 hours. And then on the scale of your large trees, those might change more even by the seasons. During winter, they have a lot more moisture. During summer, they get a bit drier. So that's why relative humidity is important because it factors into your fuel moisture. And the closer your fuels are to just being completely dried out, the closer they are to where they could be combusted. And the easier it is for those plants to combust. So when a fire is coming in, before it can catch that bush on fire, it has to evaporate the moisture out of that bush. It has to dry it out. So the fire has to use some of its energy to dry out that plant. So if your bush has more moisture, then the fire has to waste more of its energy just evaporating the moisture before it takes its remaining energy to burn up the bush. So if your bush is already very dry, then the fire just gets to it and it bursts straight into flames. So that's maybe where we could also tie that back into precipitation. That's also going to impact your fuel moisture. In California, we have a Mediterranean climate, so most of our rainfall is picked up during the winter, and then it's very dry during the summer. The reason I messed up right there is because I was thinking about the fact that during the summer, we do get thunderstorms, and then that can bring some rainfall in. And that was something that we have seen this last summer, but usually your thunderstorms don't bring enough rainfall to really impact your fuel moistures. What we learned is you need about 0.1 inches to really bring some moisture back into your grasses and reduce fire danger. You need about 1/4 of an inch to 1/2 an inch to bring it back into your trees. And a lot of thunderstorms move through pretty quickly, so yeah, it's a question mark whether you'll actually get 1/4 of an inch to 1/2 an inch. And I believe brush was included in that grass equation where you maybe only need 0.1. I'll have to look back into that one. Or you can watch one of my old videos that I recorded this week. So temperature or precipitation, obviously, the more rainfall you get, the more moisture is going to be in your fuels. Typically, now I say typically because at a certain point, your soils will become saturated. It's almost like a sponge that can't absorb any more water. So instead of actually absorbing more water, then more rainfall would just lead to runoff. So that's the one kind of piece of nuance that I have to put to that, because technically it's not completely accurate just to say more rainfall equals higher fuel moisture. Once the soils are saturated, then any additional rainfall is just going to turn into runoff. But you could also say that maybe rainfall was a part of the reason we didn't see the fires take off today, and why maybe the alarm bells didn't start ringing in my head is just last week we picked up about 1/4 of an inch to 1/2 an inch in the Big Sur area and the Santa Cruz Mountains. And that's enough to bring some moisture back into your trees. And that's not the only rainy system we've had recently. We had maybe a couple systems come through during summer. Those are more thunderstorms, though. It didn't bring that much rainfall. Had a couple spring storms. Don't know if you'd really call them storms, but some wetting rain. And then winter, we picked up about 2 times as much rainfall as you would expect. So we started off this fire season with a lot of moisture in our fuels. And then we picked up some more last weekend. So that may have been also part of the reason that I wasn't too concerned about the fires today. So we've talked about temperature, relative humidity, precipitation, and then we'll just go into the other one that factored into the fires today and why my alarm bells didn't go off, which is wind. So wasn't all that windy today, and if it's not that windy, a lot of times you can tell just based on the video of the fire because the smoke plume will be going straight up. Whenever I see a smoke plume going straight up, I think, it's going to be moderate growth at the fastest. Because, maybe I shouldn't go that far, but on windy days, that smoke plume is going to be tilted over, and then that's going to be when you see a lot faster fire spread. Reasons for that: one, wind can provide more oxygen to the fire, just like when you're starting a campfire and you kind of breathe on it, and it starts to glow a little bit hotter. Maybe even the flame starts after you blow on it. So you're providing more oxygen. The wind can also create spot fires. That's maybe the number one danger that wind brings to fires, is it can pick up burning embers, toss them out ahead of the major blaze, in some cases past the defenses firefighters have been putting in, like fuel breaks, can just toss I think you call it a firebrand or an ember or a spot fire over that fuel break, and then all of a sudden you have a new fire that can start taking off. It also just pushes the flames forward, and then it also dries out the vegetation faster, because there's no wind, you have your fire, and all the heat is just going straight up. Whereas when there's wind, some of that heat is going to be actually blowing more horizontally, and that heat will be able to dry out the fuels before the fire gets there. Ties back into what we were talking about with fuel moisture. So if the plants are already dried out because the wind has blown in that warm air, and in some cases the wind can also kind of pull out the moisture, then the fire doesn't need to use its energy to evaporate the moisture. It's already gone, so then the fire just quickly spreads through the landscape. And then kind of expanding on that further, your flames are also going to be tilted over. So then the flame itself is actually closer to the vegetation that it's about to catch on fire. That's going to dry it out faster as well. So good news, we didn't have windy conditions today, so it seems like they got the fires taken care of pretty quickly. Again, stability was the last factor that I think I already talked enough about throughout the course of this video, but just know that unstable atmosphere is typically going to lead to more extreme weather conditions, whereas a stable atmosphere or an inversion can really reduce your conditions. And one thing that I should say that I use in wildfire forecasting a lot is sometimes you'll have an inversion in a valley in the morning. So let's say overnight your mountain slopes cooled off a lot, and then that cold air pooled down into the valley because it's more dense. So you're starting off the day with cold air at the bottom of the valley, and then what you'd call a thermal belt around kind of more where your mountain slopes are. So it's cold air below warm air, very stable. And then most days that inversion is going to mix out as you get into the afternoon, because then instead of your mountain slopes cooling down faster than your valley bottom like they do at night, which leads to the cool air sinking down, in the afternoon your mountain slopes are going to heat up faster than the valley bottom. So then you get a lot of rising air, and then you get air lifting up out of the valley, and you get upslope winds. That's a huge thing that has to do with stability and winds. That is a big part of the diurnal pattern that we see in wildfire behavior, where in the afternoons your fires go uphill because you have those up canyon or up valley winds. You call them valley winds because mountain slope heats up faster, air rises, air replaces. Now, when you have that inversion in the morning, one thing that can keep it in place, this is what I was getting to, which is a tool that I use in wildfire forecasting, is let's say you had very extreme fire conditions the day before and the fire produced a large amount of smoke, and you still have a lot of that smoke over your fire, and maybe it's right around that inversion, so it's just sitting there. Then all of a sudden, the sunlight can't get in to heat up the mountain slopes, so then you don't have that wind, and you don't have that mixing, and you don't have the heating, and then that can actually just lead to stable conditions all day long. And I have seen this happen on a few fires where I'm expecting the usual afternoon winds to start going upslope in the afternoon. You get your fastest fire spread of the day because it's the hottest time of the day, the driest time of the day. It'll be the windiest time of the day. And flames already like to go uphill because of that flame tilting factor where they're closer to the fuels uphill. But then you have a lot of smoke over the fire, and then it's almost like a negative feedback loop where a lot of fire activity the day before led to so much smoke that it blocks out the sun the next day and it reduces fire behavior on the current day. So again, lots of different factors that come into play, and that's why wildfire forecasting is pretty, I don't want to say fun, because it's you could definitely describe it as serious work. In some cases it's life or death, but it's maybe fulfilling is the right word, because there's something that you can learn every single day. I always think of this when I go surfing. It can be the worst waves ever. It could be 2-foot onshore shore break, windy, terrible conditions. But if throughout that session, maybe I do like one little turn or like one little cutback that I haven't really done before, and I feel like I learned something new, then the whole session was well worth it. And it's the same thing with wildfire forecasting. I've been doing it for, I think, 3 years now, and every single day there's something new that I learn. And that's kind of the basis of these videos. It's also part of the reason I'm reading this textbook right now, is just to continue that, and not only continue, but to speed up that learning process while simultaneously increasing my ability to communicate what I learned. So I'm going to keep up with this. I find it very interesting. If this piques your curiosity as well, there's more to come, so you can stay tuned. And thanks for watching.